Hi all and welcome to a new video. In this video, we will cover a very important concept in data analytics and data modeling, that is entity relationship diagram. This is a very important concept in data analytics because as a data analyst or a data engineer or even a data scientist, we will come across entity relationship diagram in most of our day-to-day activities because entity relationship diagram helps us gather lot of information about our tables and database. Entity relationship diagram helps us identify the table structure along with column names and data types. Also, it helps us identify primary key, foreign key, and other constraints associated with the tables. Also, it will help us identify the relationship between different tables in a database. All this can be identified from the entity relationship diagram. So, in this video, we will take a closer look at what is an entity relationship diagram, and we will create an entity relationship diagram in SSMS. So this is our basic agenda throughout the video. First, we will see what is a entity relationship diagram, then why entity relationship diagram is important, then we will go through components of an entity relationship diagram, then we will go to SSMS and we will try and create an entity relationship diagram. Finally, we will see what is the difference between a data model and an entity relationship diagram, because it is very much similar, but there are differences between data model and ER diagram. First of all, what is an ER diagram or an entity relationship diagram? Basically, an ER diagram is a visual representation that illustrates the entities. Entities means objects or concepts. If I come to this specific example, which is shown here, the department, employee, folder, country are different entities or objects. And the next thing is attributes, which is properties of character, properties or characters. And if I come to the example, department, if I take the entity department, department ID, department name, and department country are the characteristics or properties of the particular entity. And then moving on, we have the relationship between entities within a system. See this example, we can see that there are different lines which are joining the different entities. So this is the lines which are showing the relationship between different tables or entities in a database. So if we take the example of department and country, we can see that there is a relationship between the entity department and country, but there is no direct relationship between country and folder. But we can establish a relationship between country and folder through department and employee. So similar things can be identified using an entity relationship diagram rather than simply writing query. So entity relationship diagram is a popular tool used in database design and conceptual data modeling. Now we will move on to the next slide, which tells us why entity relationship is important. There are many reasons for which we need an entity relationship diagram. Here I have listed the main 4 reasons why we need an entity relationship diagram. The first reason is database design, because ER diagram allow designers to conceptualize the entities within the system, their attributes and their relationship between them. We already saw what is an entity, attribute and relationship in the previous slide. That is, here department is the entity, the columns within department is the attribute, and relationship is the line which is joining different database tables. And this understanding is fundamental in creating a well-organized, efficient database structure, because sometimes without visualizing, it is very difficult to understand what is the relationship between different tables in a database. It might be easy when we have small number of tables, like 3 or 4 tables are there, then it is easy to identify the relationship. But in actual projects, the number of tables will be huge. So that time, having an ER diagram is very important, and it will become very easy for us to identify different tables. And even when writing the query, it is easy to organize the query and efficiently write queries if we have a proper ER diagram. Now, the second reason is identifying a relationship. ERDs helps in identifying and defining the relationship between different entities, such as one-to-one, one-to-many, many-to-many, and many-to-one. So these are the different kinds of relationship that we can have with different tables. Understanding this relationship is essential for maintaining data integrity. So this understanding of the relationship between different tables is also very important when maintaining data integrity and writing queries, because based on that only, even when using some kind of window functions or some aggregate function, we will be able to manipulate the query in a very efficient manner if we know precisely what is the relationship between different tables. Now coming to normalization. Normalization is a technique used to reduce data redundancy and improve data integrity. ERDs aid in identifying dependencies and normalizing the database structure. So normalization is actually a very huge concept. I'm actually coming up with a video on normalization. In that I will explain in detail what is normalization, and we will see how to actually normalize a table, and we will create multiple tables which are normalized from a denormalized table. Now coming to planning and scalability. ERDs help in planning for scalability and future modification. Designers can anticipate potential changes and adapt the database structure accordingly. So this is pretty obvious from the previous image itself, because once we have a closer understanding of our database structure, it is very easy to scale or very easy to add tables and establish relationship between tables. Otherwise it becomes very difficult, and even if we create some relationship or establish some constraints on tables and all, later on it might create some problem if we do that without proper understanding of our database. So these are the main 4 reasons why we should have a ER diagram, and there are many other reasons as well, but I have listed only very important 4 reasons. Now moving on to next one, which is components of entity relationship diagram. Entity relationship diagram has mainly 4 components. The first one is entity, that is objects or concepts in a system that are represented by rectangles in the diagram, which we saw in the first slide. Then attributes. Attributes represent properties or characters of entities and are depicted within the entity box. Basically attributes are columns. If we take the tables as an example, attributes are basically columns which are telling different characteristics or attributes itself of the entity. Then coming to relationship. Relationship describe how entities are related to each other. They are represented by lines connecting the entities and typically labeled to define nature of the relationship. So the label will also differ depending upon what sort of a relationship is established between different tables. So it can be one to one, one to many, many to many, or many to one. So based on that, the labels to define the relationship will also vary. And finally, cardinality. Cardinality in ER diagram indicates the number of instances of one entity that can be associated with the number of instances of another entity through a relationship. It defines the participation of entities in a relationship such as one to one, one to many, many to one, etc. This is very similar to the concept of relationship. Then moving on to the next slide. Here we will see how to create an entity relationship diagram in SSMS. So now let me take you to SSMS, and there we will see how to create an entity relationship diagram. Yeah, so now we are going to create an ER diagram using SSMS. For that, I already have created one database called as ER model, and I'm going to use this database, which is ER model, to create the tables and then create ER diagram based on the tables. Here we are going to create 4 tables, which are, the first one is country, second one is department table, third one is employee table, fourth one is folder table. Let me take you through each tables and their schema. So in the country table, we have 4 columns, which is country ID, which is basically an integer, and we have given one more constraint, that is identity, which means that ID will be incremented automatically starting from 1 and will be incremented by 1, and this is the primary key for the column. Secondly, we have country name, which is a variable character. Similarly, we have continent and currency. And coming to the department table, the table name is department. We have the first column as department ID, which is an integer and which is the primary key for that particular table. And we have department name, which is variable character, and country ID, which is an integer, is referenced as the foreign key for the first table, that is country table. So here it is specified that country ID, which is an integer, is a foreign key which references country, which is the table name. Inside the parenthesis, we have specified the column to which it is referenced, that is the country ID column in the first table. So this is a foreign key in the department table. Now coming to employee table, we have the first column as employee ID, which is an integer and primary key for the employee table, then employee name. Then coming to department ID is a foreign key which is an integer and references to the department table, and the column is department ID, which can be null, that is specified with null constraint. So this department ID in the employee table is referencing the department ID in the department table. Now coming to the fourth table, which is folder table. Folder ID, which is an integer, not null. We are not specifying any primary key constraint over here. And employee ID, which is an integer, references employee table, and the column is employee ID. So this column references to the employee ID column from the employee table. And we have one more column in the folder table, that is access type. and that is variable character, and it can be null, which is specified by null, and not null specifies that the column cannot contain any null values. Now let us go ahead and create this for tables. Execute this. Now command completed successfully, so these tables should be created under the ER model. Now we can see that these 4 tables are successfully created inside the ER model. Now let us create a ER diagram based on the 4 tables. So here you can see one more option called as database diagram. So let us right click on that, choose the first option, which is new database diagram. Click on that and choose tables one by one. So I'm choosing the first table as country, then let me take department, employee, and folder. Now I have all the 4 tables in the diagram. Now we have the simple ER diagram created in SSMS. As you can see, here we have the country table, which has a primary key country ID and which references to department table with the country ID primary key, and here the country ID is the foreign key. Similarly, department table is connected to employee table through the department ID primary key from the department table and department ID foreign key from the employee table, and employee table is further connected to folder table through the employee ID column. Also, depending upon the tools we are using, we might get more information from the ER diagram. Let me show you one ER diagram which I have created using another tool. So this is another example of an ER diagram which I have created using another tool. This ER model shows us few more things compared to our previous ER model which we created in SSMS, because here we have the data type for each attributes or columns. Also, we have the cardinality which we can read from the line which is shown here. So if I take this customer and order table, this customer to order table is a one-to-many relationship. That is, one customer ID can be related to many orders that we can read from the table, because here it is depicted 1 and here it is depicted many. So this we can read as one-to-many relationship. Also, there are other tools as well to create the ER diagrams. Now we have created our ER diagram in SSMS. Now moving on to what is the basic difference between data model versus ER diagram. ER diagram is a visual representation of the data model, but they are not precisely the same thing, because data model is a very huge comprehensive concept. It refers to an abstract model that organizes the element of data and how they relate to each other in the real world. A data model can be represented in various forms, such as conceptual data model, logical data model, and physical data model. Actually, we can have ER diagrams in all 3 of these data modeling steps. We can have an ER diagram in a conceptual data as a conceptual data model. We can have an ER diagram as a logical data model, and after we create a physical data model, we can depict that as well as a ER diagram. So ER diagram is actually not a data model, but ER diagram is actually a tool which comes under data modeling. So we can conclude that ER diagram is not actually a data model, but one component of the data modeling concept that we can use at any stage of the data modeling process. And if you want to download this PPT, I will give the link in the description. You can go ahead and download the PPT. Thank you.